All right, so let's first recall quickly what power is. So when you have the node distribution and the alternate distribution, to calculate power, you first find the critical point. Outside the critical point is the rejection region. And the power is the number, is the area under the alternate distribution within the rejection region. So the area of this part is the power. Okay, so there are several ways to increase the power. So first, we can increase power by increase alpha, which is the significance level. Okay, so let's see what happens when we increase alpha. So alpha doesn't change the node distribution and alternate distribution. But if we increase the value of alpha, then the critical point moves to the left. Move to the left because alpha increases. So if the critical point is moved to the left, then the rejection region is larger, and therefore the power is larger. Yeah, so that's one way, but this is not recommended because alpha bounds the probability of type 1 error. So if you increase alpha, you increase power, but you also increase the chance of type 1 error happening. So increasing alpha is not good because we are basically, what we're doing is we're trading off type 2 error with type 1 error. So it's not really recommended. All right, so that's one way. And the second way, you have seen it in the previous example, you can choose the alternate distribution to be further from the node distribution. Okay, so let's draw that again. So the node distribution never changes. But if we choose the alternate distribution to be further from node distribution, let's make it drastic. So like that. Because the node distribution is the same, so the critical point is the same. That means the rejection region is the same. But because the alternate distribution is moved further to the right, so the area under the curve above the rejection region is larger, so the power is larger. So that's the second way to increase the power. And the third way, let me erase this, which is the most common way. So the third way is to increase sample size. This is the recommended way. So recall, we always say that the larger the sample size is, the better anything is. And that's true. So if we increase the sample size, this means, remember the standard deviation is given by sigma over the square root of n. And because n is in the denominator, it increases, so the standard deviation decreases. So the distributions are thinner. So let me draw that. So the node distribution and alternate distribution still have the same mean, but they have smaller standard deviation, so it looks like that. So thinner node distribution and thinner alternate distribution. And because the node distribution is thinner, so the critical point is moved to the left a little bit because it should be closer to the mean now. and the rejection region is larger. And all these together definitely gives you more power. Alright, so the main way to increase the power is to increase sample size. That's definitely the case. So let's do an example. So let's use the same number as the previous one. So the null hypothesis is mu less than or equal to 80. Alternate hypothesis is mu greater than 80. And alpha, alpha is 0.05. And sigma, standard deviation is 5. And the alternate distribution is 81. Mu equal to 81. 81. If we want to see how big the sample size should be to make the power equal to 0.9. Sorry. All right, so let's draw the two distributions. So we have the null distribution. The mean of the null distribution is 80. We don't really know exactly what the standard deviation is because we don't know the sample size. So the variance is 5 squared over n. N is unknown. And the alternate distribution has the same standard deviation, but the mean is 81 because we chose 81, and the variance is 5 squared over n. Okay. So imagine somewhere here there is a critical number, critical point. Okay, let's call it x. Why not? So the critical point is x. So we have two clues. X is a critical point for the alpha equal to 0.05. So that means the z value, which is x minus 80 over 5 over root n, this is equal to 0.05, gives you the z-score 1.645. This is z sub 0.05, by the way. So that's one clue that comes from the null distribution. But another clue that comes from the alternate distribution is the power is 0.9. So that means the power area of this part is 0.9, which tells you the area of the other part is 0.1. So the z-score, which is x minus 81 over 5 over root n, this is equal to negative z sub 0.1, which is 1.28. Well, these two equations, so the first equation tells you that x equals to 80 plus 1.645 times 5 over root n. The second one tells you that x equals to 81. Oh, I forgot a negative sign here, sorry. 81 minus 1.28 times 5 over root n. But these two numbers have to be the same because they're both x's. So we can solve 80 plus 1.645 times 5 over root n equals to 81 minus 1.28 times 5 over root n. You can use a calculator to solve this. N has to be at least 214. So this is the smallest size n has to be to make the power equal to at least 0.9. All right.